Have you ever noticed that modern buildings don't last at all? Buildings crack, bridges collapse, and roads wear out quickly. But 2,000 years ago, the Romans had already solved this problem. They created a concrete so strong that it remains intact to this day. While our constructions do not come close to that durability, science has finally discovered the secret of this lost technology, and what has been revealed could change everything. Stay with me, because today you will understand the millennial secret of Roman concrete, what science has finally revealed. Just imagine, you are walking through Rome and you come across the Colosseum, a giant building that has been through earthquakes, wars, and even bombings but is still standing. Now think, why do modern buildings start to crack after a few decades? How did an empire from 2,000 years ago manage to make something so resilient while today bridges crumble, dams need constant repair, and skyscrapers turn to dust over time? What did the Romans know that we have forgotten? This mystery has puzzled scientists for centuries. They have already analyzed the ruins, tried to reproduce the concrete used at the time, studied old documents, but it seemed that there was always a piece missing from the puzzle. The answer was right in front of them all this time, and only now can we understand. The Romans not only created an extremely strong concrete, but a material that repairs itself. Yes, you heard that right. Roman concrete has a curing mechanism that causes small cracks to disappear over time. This could change everything we know about engineering. Imagine a building that, instead of needing constant maintenance, simply repairs itself. Roads that don't need renovations every few years. Bridges that last for centuries without needing repairs. It sounds like science fiction, but the Romans were already doing it even before the invention of electricity. But calm down. How does this work? And why did this technique disappear? That is the big question. For a long time, researchers thought that the secret lay in the materials used by the Romans, such as volcanic ash and limestone. But that wasn't the full explanation. The real secret was in a detail that went unnoticed for centuries. Small fragments of quicklime inside the concrete. When the concrete cracks and comes into contact with water, these fragments react and fill the cracks. It is as if the material is alive, always regenerating. Have you ever felt that the stories you know about Rome are always the same, without the real details, emotions, and strategies that defined the greatest empire in history? With that in mind, I created the 10 battles that shaped the empire. This book gets straight to the point, clear, moving, and never-before-seen explanations of how legendary leaders turned battles into historic milestones. You no longer need to get lost in confusing reports. Click on the pinned comment and download now the 10 battles that shaped the Roman Empire. But beware, it is for a limited time. Transform the way you see history and discover what has always been missing in the narratives you thought you knew. Now stop and think. If this technology is so revolutionary, why don't we use it today? Well, that's where a problem comes in. Modern concrete is made to be cheap and fast, but not necessarily durable. Buildings need constant repairs, and this generates a billionaire market for maintenance companies. Did we ignore this knowledge because it was not profitable, or have we simply lost it over time? The most impressive thing is that this recent discovery could change everything. There are already scientists working to bring this technology back, and early tests show that we could build entire cities with buildings that last much longer and with lower maintenance costs. But will this idea really be applied? Or will large companies continue to bet on constructions that need constant renovations? And now I ask you, are we making a mistake by ignoring the knowledge of the past? If the Romans developed something so incredible 2,000 years ago, why did modern engineering abandon this idea? It would be much cheaper and more efficient to build with this type of concrete nowadays, but for some reason, this technology has been forgotten. Or rather, it was ignored. Before continuing, I saw here that you forgot to subscribe to the channel. You won't want to miss all the content about Rome that we will always be bringing. Have you ever stopped to think about how the Romans built buildings that are still standing after 2,000 years, while modern buildings begin to crumble after a few decades? Not only did they invent concrete, but they created a version far superior to the one we use today. And most impressively, this technology has been forgotten for centuries. Roman concrete, called opus caementicium, seemed ordinary at first glance, but it hid a secret. Unlike modern cement, which cracks and wears out over time, it had a special trick. It could repair itself. This meant that any cracks were automatically closed, preventing deterioration. It may seem like a futuristic concept, but the Romans had been doing it for thousands of years. Records from the time describe the recipe for concrete: volcanic ash, quicklime, and stones. Scientists have known about this composition for a long time, but it was not understood why this material was so durable. Only recently have researchers discovered the secret. Upon examining Roman concrete, they found small white fragments in the mixture. At first, they thought they were impurities, something the Romans were unable to remove. But after many tests, they realized that these fragments were actually pieces of quicklime, an essential component for the material's strength. Quicklime reacted in a unique way. Whenever the concrete suffered small cracks, rainwater would enter and activate these particles, which then hardened and sealed the crack. In other words, the material was able to regenerate. The more time passed, the stronger he became. In modern cement, the opposite happens. Any crack allows water to enter, which weakens the material and causes corrosion in the internal structures. Over time, concrete wears out, and buildings need frequent repairs. Roman concrete, on the other hand, did not need this. It lasted for centuries because it grew stronger naturally. The question that no one wants to be silent about: why did we stop using this technology? The answer lies in history. With the fall of the Roman Empire, much knowledge was lost. The engineers who mastered this technique disappeared, the records were forgotten, and over time, the formula ceased to be used. By the time concrete became popular again centuries later, Roman technology had already been erased from humanity's memory. Another important detail: modern cement, even though it is inferior, has become extremely profitable. If the buildings were made to last for centuries, as they did in the past, the maintenance sector would lose money. Today's concrete needs constant renovations, which maintains a continuous cycle of spending and profit for the construction industry. Now that this formula has been rediscovered, scientists are already testing ways to bring this technology back. The idea is to develop a modern concrete inspired by the Romans, which regenerates itself and lasts much longer. Some tests have already shown promising results. But will this really be applied on a large scale? There are still many unanswered questions. Is modern engineering willing to change its approach and invest in more durable constructions? Or will they continue to use short-lived materials to keep the renovation market always warm? In any case, one thing is certain: the Romans were far ahead of their time, and we are only now beginning to understand the grandeur of their constructions. And you, what do you think? Do you believe that we can recover this knowledge and use it today? Tell me here in the comments. I want to know your opinion. For centuries, scientists have tried to understand how the Romans created such sturdy concrete. Their buildings have endured wars, earthquakes, and millennia of natural wear and tear, and they are still standing. Meanwhile, modern buildings crack after a few years of use. But now, finally, science has found the answer. And believe me, the secret was right in front of our eyes all along. What researchers have recently discovered is something incredible. They analyzed samples of the Roman concrete using electron microscopy and noticed something strange: small white fragments scattered throughout the mixture. At first, they seemed like impurities or manufacturing defects, but these fragments were actually the key to the longevity of this material. These particles were made of quicklime, an ingredient that the Romans added to the mixture. But what is the importance of this? Simple. When a crack appeared in the concrete and water penetrated the structure, these particles reacted chemically and automatically filled the cracks. This prevented the crack from expanding and weakening the building. In other words, Roman concrete literally repaired itself. This natural healing effect explained why many ancient buildings not only survived, but seem to have grown more resilient over time. Unlike modern concrete, which begins to deteriorate as soon as the first crack appears, Roman concrete grew stronger and stronger. To test this finding, scientists recreated the ancient concrete in the lab. They broke samples on purpose, added water, and waited. Within days, the fissures began to close on their own. This means that 2,000 years ago, the Romans inadvertently invented a self-healing concrete, something that modern engineering is only now trying to develop. And the impact of this can be gigantic. Imagine if we could build entire cities with buildings that don't need constant maintenance, bridges that would never need structural reinforcement, roads that do not form potholes. This could save billions in repairs and completely transform the way we design buildings. But there is a problem. Modern concrete, made of Portland cement, dominates the market. It is cheap, easy to produce, and generates an endless cycle of renovations and maintenance, which keeps the construction industry always profiting. If all buildings were made with a material that practically does not need repairs, many people would lose money. And that's not all. The production of modern cement is one of the biggest environmental villains in the world. The manufacturing process releases tons of carbon dioxide into the atmosphere, contributing to global warming. Roman concrete, on the other hand, because it uses natural materials and depends on different chemical processes, could be a much more sustainable alternative. Even so, some scientists have already begun testing ways to bring this technology back. The challenge is to find a way to adapt it for modern construction, making it viable for large-scale production. The first tests are promising, but the big question is, will this technology really be used? The fact is that the Romans were far ahead of their time, and only now can we understand the true potential of what they created. The question that remains is, will we take advantage of this discovery to change the future of engineering, or will we continue to be stuck with inferior materials for convenience? If there's one ingredient that has made Roman concrete survive for centuries, it's volcanic ash. It may seem strange, but the Romans discovered that this material made all the difference in the strength of their buildings. While modern concrete begins to crack after a few decades, Roman structures remain firm, even after 2,000 years. It all started in Pozzuoli, a town near Mount Vesuvius. There, the Romans found large deposits of pozzolana, a volcanic ash filled with special minerals. When mixed with lime and stones, this substance created an extremely durable concrete. The result? A material that not only resisted time but became stronger and stronger, and the proof of this is in the buildings that came into direct contact with salt water. If you've ever seen modern ports, docks, and bridges near the sea, you know that they live under maintenance. Seawater corrodes concrete quickly, weakening structures, but Roman ports are still standing, even after 2 millennia of exposure to the waves. Scientists decided to investigate and discovered something incredible. When seawater penetrated Roman concrete, it did not destroy the material, but strengthened it. This happened because of the minerals present in pozzolana. Instead of weakening the structure, the chemical reaction created new crystals that filled cracks and prevented erosion. In other words, Roman concrete not only resisted salt water, but regenerated over time. While modern concrete wears out and needs constant repairs, the concrete of the Romans grew more solid with each century. Now, imagine the impact of this. If this technology were applied today, we could build ports, bridges, and dams that would be virtually maintenance-free. Coastal cities would be safer, and infrastructure costs would fall dramatically. In addition, there is another important factor. Modern cement is one of the biggest pollutants on the planet. The production of this material releases tons of CO2 into the atmosphere. Roman concrete, on the other hand, by using volcanic ash, was much less harmful to the environment. But, as with other secrets of Roman engineering, this technique was forgotten. With the fall of the empire, knowledge about pozzolana disappeared, and humanity went centuries without exploring this material. Today, almost everything we build relies on Portland cement, which may be more practical, but it is nowhere near the durability of Roman concrete. The good news is that scientists are starting to rediscover this technology. Recent studies have shown that replacing some modern cement with volcanic ash can reduce carbon emissions and increase the strength of buildings. But there is a challenge. The process needs to be adapted to work on a large scale. And there is still another detail that few know. The strength of Roman concrete came not only from the pozzolana, but from the way it was mixed. Unlike today's industrial methods, the Romans mixed ingredients unevenly, creating layers that reacted over time. This means that, in addition to the material itself, the manufacturing process also made all the difference. Now that this discovery has been made, the question is, will modern engineering really invest in this technology? Or will we continue to use an inferior material just because it is more convenient for the industry? One thing is certain, the Romans were far ahead of their time, and perhaps the key to more durable and sustainable buildings has always been in the past. And don't forget to pick up your digital book, 10 Battles That Shaped the Roman Empire. It's important that you get it right now before the units run out. The Romans didn't just invent a sturdy concrete, they knew exactly how to use it. Their constructions were not made to last a few decades, but to defy time. While modern buildings begin to deteriorate rapidly, Roman works are still going strong after 2,000 years. This was no coincidence. One of the best examples of this genius is the Pantheon in Rome. This building has the largest unreinforced concrete dome in the world, and to date, no one has been able to replicate it with the same efficiency. No beams, no central columns, just a gigantic dome, 43 meters in diameter, defying gravity and resisting earthquakes and erosion. How did they do it? The secret was in the way they distributed the weight. Instead of using uniform concrete, the Romans applied an ingenious trick. They placed denser concrete at the base and lighter material at the top, including volcanic pumice. This reduced the pressure on the foundations and prevented collapses. And it wasn't just that. They also mastered the art of arches and vaults, structures that redirected weight, preventing one part from overloading the other. This technique was used in underground heaters, aqueducts, and even the Colosseum, which survived centuries of battles, fires, and even bombings. But the genius of the Romans went beyond the concrete. They also mastered the construction of ultra-strong foundations. Unlike many modern buildings, which give way due to unstable soils, the Romans planned their constructions to absorb impacts and adapt to the terrain. In earthquake-prone areas, they created layers of sand, gravel, and flexible concrete, which acted as a kind of buffer, reducing the effects of the tremors. Something similar to modern anti-seismic systems, but made more than 2,000 years ago. And one more detail: the Romans did not follow a single construction pattern. They studied the environment before erecting a structure. If they were near the sea, they used concrete with volcanic ash that resisted salt water. If they were in seismic regions, they reinforced the foundations. This care with materials has helped many of these constructions survive, while many modern buildings collapse because they were not designed for the environment where they were built. Another essential factor was the way they organized the cities. They not only erected buildings, but created extremely efficient infrastructure systems, paved streets, drainage systems, aqueducts that carried clean water miles away. All of this was planned to last. In addition, urban planning included open areas, such as amphitheaters and forums, designed to accommodate thousands of people without compromising the structure over time. Every detail of Roman constructions had a purpose, and the engineering was so advanced that many of these structures are still in use. Today, many works have a short, useful life. Buildings need constant renovations, bridges crack over time, and entire cities enter a cycle of construction and demolition. The Romans, on the other hand, thought differently. They designed everything to last for centuries, maybe even forever. Modern engineering has more technology, precise calculations, and advanced materials, but it seems that we are still far from the efficiency that the Romans achieved. Have we built too fast and forgotten how to build to last? Or did profit and haste prevent us from following this path? The fact is that the Romans knew exactly what they were doing. And the most impressive thing, his constructions continue to prove this to this day. If Roman concrete was so strong, why did it disappear? How could something so amazing simply be forgotten, while today we use a much weaker material? The answer has everything to do with the fall of the Roman Empire and the knowledge blackout that followed. In Rome's heyday, engineers knew exactly how to create structures that lasted for centuries, but when the empire began to crumble, this knowledge gradually disappeared. The collapse of Rome in the 5th century was not only a political crisis, it was also the end of an era of advances in engineering and architecture. Cities were looted, libraries burned, and the engineers who mastered these techniques simply disappeared. Roman concrete depended on a very specific process which was not passed on, and with no one to teach, the formula was forgotten. The Middle Ages were a time of much simpler constructions. The sophisticated techniques of the Romans gave way to a more basic system, with stone and mortar. It wasn't bad, but it was far from having the durability of old concrete. The builders of the time had no idea what they were missing. The most curious thing is that the Romans built to last for centuries, while many medieval buildings needed constant renovations. Something that had already been solved 1,000 years earlier was completely ignored. Over time, other techniques were developed. Baked bricks, reinforced steel, common cement, but none of these materials came close to the durability of Roman concrete. Still, no one has tried to rescue this technology. Then came the 19th century and the emergence of Portland cement, the basis of modern constructions. It was practical, cheap, and dried quickly, but there was a problem. It didn't bring the secrets of Roman concrete. It didn't regenerate. It didn't stand up to time as well, and of course, it didn't last 1,000 years. The result? modern buildings much more fragile. While Roman aqueducts and temples are still standing, many of today's bridges and buildings are already in need of repairs in a few decades. But the most impressive, only now have scientists begun to understand how Roman concrete really worked. By analyzing samples, they discovered that it had properties that could revolutionize modern engineering. A stronger, more sustainable concrete capable of repairing itself. If this knowledge had never been lost, imagine how different cities would be today. Fewer renovations, fewer cave-ins, less maintenance costs. But somehow this advance was ignored for centuries. Now that science has finally rediscovered this secret, the big question is, are we going to use this knowledge to transform engineering, or are we going to keep building so that everything needs to be fixed in a few years? The truth is that the Romans already had the answer. It only takes us 2,000 years to realize. Now that scientists have finally deciphered the secrets of Roman concrete, the big question arises, can we use it again? The answer is yes. And more than that, this technology can completely change the way we build. For more than a century, Portland cement has dominated the construction industry. It is cheap, easy to produce, and dries quickly. But now we know that there is something much better. The Romans created a much more durable, sustainable, and intelligent concrete. And the best, it can be recreated. Researchers have already begun testing Roman-inspired concrete, mixing volcanic ash and activated calcium to develop a material capable of regenerating itself. This means that cracks and fissures would no longer be a problem. Minor damage would disappear on their own, extending the life of buildings. In the first tests, the results were incredible. The new concrete withstood extreme conditions, filled cracks naturally, and showed a level of durability that could revolutionize engineering. If this technology is implemented on a large scale, we could have buildings, bridges, and roads that last for centuries without needing constant maintenance. But here comes the big question. Why aren't we using this material yet? The answer is simple. The construction industry is not prepared for this change. The market revolves around Portland cement, which needs constant repairs and keeps maintenance companies always making a profit. A concrete that lasts hundreds of years would completely change this scenario. Even so, some large companies have already realized the potential of this material and have begun to test its use. Experimental projects are incorporating volcanic ash and special minerals into the production of modern concrete. The goal is to create a version adapted to current needs without losing the impressive resistance that the Romans managed to achieve. If this technology is adopted, the impact will be gigantic. Imagine cities built with buildings that don't need frequent renovations, bridges that withstand natural disasters without collapsing, roads that do not develop cracks over time. This could drastically reduce maintenance costs and make urban infrastructure much safer and more reliable. And in addition to durability, there is another great advantage: sustainability. The production of traditional cement is one of the largest contributors to CO2 emissions in the world. Roman concrete, on the other hand, can be produced in a more environmentally friendly way and still absorb carbon from the atmosphere, reducing the environmental impacts of civil construction. Another important issue is that Roman concrete was extremely versatile. It was used in ports, temples, aqueducts, and even in submerged structures, which resist to this day. If this technology is adapted correctly, it can be applied to almost any type of modern construction, making cities more durable and efficient. The problem is that this transition will not be easy. Implementing this technology on a large scale requires changes in the production process, adaptation in factories, and above all, a new business model for the construction industry. And as we've seen before, big changes don't always happen fast. But the truth is that we are very close to seeing this revolution happen. After centuries of being forgotten, this technology may finally come back to transform the future. And ironically, that means looking to the past and learning from the Romans, who already mastered this art 2,000 years ago. The greatest teaching of Roman concrete is not only about engineering, it's about how knowledge can be lost and rediscovered. For centuries, we have had before us a technology that is much stronger than modern concrete, but we simply ignore its existence. And why? First, because the formula was lost with the fall of the Roman Empire. Without engineers to pass on the knowledge, this technique disappeared. But there is another reason: the belief that the past has nothing to teach us. For a long time, we assumed that the Romans were less advanced than we were. Thinking that antiquity could not offer us something better caused this technology to be forgotten. Now that we've rediscovered this secret, we have a unique opportunity to use the past to transform the future. Roman concrete is just one example of what may have been lost throughout history. Think about it. How many other incredible discoveries may have disappeared in time? Did the ancients master techniques that we have not yet been able to recreate? How many innovations have simply been erased by history, war, or oblivion? The truth is that progress does not always mean leaving the past behind. Sometimes the best innovation is to rescue something that has been done before and improve it. If the Romans managed to build buildings that have endured for 2,000 years, while our modern buildings need renovations in a few decades, are we really moving forward, or just building fast and cheap without thinking about the long term? Now that this knowledge has been rediscovered, it's up to us to decide. Are we going to use it to change modern engineering, or do we continue to ignore the past? Maybe it's time for us to look back to finally move on. Now you know the millennial secret of Roman concrete, and how science has finally revealed a mystery that has been hidden for centuries. While our modern buildings begin to crack within a few decades, the Romans created concrete so sturdy that it is still standing after 2,000 years. It makes us wonder, how many other amazing technologies from the past have been forgotten? For a long time, we believed that everything modern is better. But what if ancient civilizations had already discovered solutions that we still don't fully understand? If we have only now managed to unravel the secret of Roman concrete, imagine what else may be hidden in history, waiting to be rediscovered. How many advanced techniques have been lost over the centuries simply because they were not recorded or preserved? What guarantees us that this is the only secret of Roman engineering that has disappeared? Did they already have other answers to problems we still face today? After all, they were able to build monuments that have stood the test of time while many modern structures crumble over the years. The big question is, what else are we leaving behind? The lost knowledge of antiquity may be the key to advances that we have not yet imagined. We need to look at the past with different eyes, without underestimating what ancient civilizations already knew. And remember, whenever you want to know how Rome became the largest empire in antiquity, just go to the pinned comment and get your digital book, The 10 Battles That Shaped the Roman Empire. Get it right now because the units are limited. Now tell me, do you believe that there are still lost technologies waiting to be revealed? If you liked this video, subscribe to the channel, and of course, like the video, because it helps me to keep bringing content like this to you.